Hey guys, I am on page 7 in your notes. So I did skip over example 6. We're going to do that in class, but I want to talk about example 7 here. So this is more looking at, before example 7, I'm sorry, categorical data. So remember, this is when you get placed in a category. It's not just a count or a measurement. So you might be placed in a category of having black hair. You might be placed in a category of living in Illinois, but it's some type of category. So if you wanted to display that, you have a couple choices. You could make a bar graph, which feels similar to a histogram, but it is not a histogram. The heights of the bars still show the frequencies or relative frequencies, which is what's similar about it. But the bottom is going to be the labels of their categorical variable. It is not going to be a numerical increment. So you could do a bar graph. Another common one is a pie chart. So you will not do these for quantitative variables, only for the categoricals. So there's steps here for creating these, but they're fairly straightforward. I'm fairly certain you've done these when in younger years. The only thing I want to remind you that we already kind of went through with the others is how to actually turn these into relative frequencies. So frequencies would be when data was collected, it was the count of these Canadian students who preferred phone calls. So there are 2 students who preferred phone calls, 1 who prefers Facebook. You can read. We would need the sum of those frequencies. I need to know in total, if I sum all these total counts, I need to know how big the group is. So this sums to 10. So if I want the relative frequency, I don't want to just know, oh, 2 people, that's not very many. You'd want to say, well, that's actually 2 out of 10. That's 20% of your data set. So you're putting it in context with relative frequency, which is the nice thing about it. 30%, 40%. Because 4 sounds like a small number until you hear it was 4 out of 10. So then once you have these relative frequencies, you can make a bar graph and you can make a pie chart. Honestly, you could have done a bar graph. You could have done a bar graph even if you had left it as regular frequencies. So let's make a relative frequency bar graph. I gave you nice numbers, so these are just going to be increments of 10. So I have equally spaced tick marks. I have a labeled axis. I have labeled tick marks. And then on the bottom, I'm just going to put a label because you have to have labeled data sets. This is the preferred communication method. That's supposed to be saying communication. So some preferred phone calls. Some preferred Facebook, some preferred in person. Almost nobody prefers Zoom, and some people prefer text messaging. So you'll notice that this is not a number line, so order doesn't really matter here. What really matters is that you just kind of keep these bars looking as close to similar, here it goes again, as close to similar as possible in width, because you're just trying to represent the height. You're not trying to say, oh, look how big this one is. You're trying to say, well, look how frequent that answer was given. So, I mean, I do have a bit of an extra gap here, which is probably not ideal, but it really doesn't matter because I'm not saying this category has a frequency of 0. There is no category there. That's what sets it apart from a histogram. So then we can also make a pie chart. Ooh, that's supposed to be a circle. There. So a pie chart. When you do a pie chart, though, you have to use relative frequency. You can't use 2, 1, 3, 4. So I'm going to attempt to make 40% of my graph made up by the text messaging group. So yes, you are capable of just eyeballing this. You could also find this interior angle. Since a full circle is 360, you could just find what 40% of 360 is. So 0.4 times 360. But I do have to label. So 40% preferred a text message. And again, as always, you are supposed to label your graphs. So this is the preferred method of communication. And then I would have 30% of my graph. That's not 30%. You would find 0.3 times 360 and attempt to make an interior angle that size. Honestly, if they get close to approximately the right size, I'm going to be plenty happy. I'm mostly looking, do you remember to come up with the labels for these? Because that's the important part to communicate what you're trying to say. So we can make a pie chart out of it. If you would ever do one of these in real life, you would not be making one by hand, so I'm not too fussed on making you do this exactly with the most precision in the world. So like I did mention though, whenever you are doing bar graphs especially, you are trying to make these look like the same width and just differing heights. So just a couple things to remember to kind of emphasize that. So this is a data set here of when Apple introduced the iMac. They wanted to know whether this computer was expanding their market share. So they wanted to know, was the customer a new computer purchaser? Did they already have a PC, or did they already have a Mac device anyway? So this is the results, and you can see there are percents on the vertical axis. It starts at 0, which is really good. It's a very misleading way to confuse statistics, is not starting it at 0. And then you see the categorical variable of previous computer along the bottom. So again, these are not histograms. They come from very different types of data sets. So if they're not histograms, do not use them to describe shape. So you can't say this is uniform or symmetric or anything like that, because the fact that I could rearrange this and I could put none on this side and suddenly it doesn't have the same shape anymore. So don't use a bar graph to describe shape. Watch your scales. I already kind of pointed out to make sure you start at 0. So if you look at this new bar graph, it's the same exact data set, but suddenly it's like, wow, these people buying this are not PC users. They're mostly already Mac users. Until you pay attention to this. That tiny little green bar is actually, if you look here, a decent chunk of their customer base. So it's misleading if you don't start at 0. So when they did this, it made the PC category appear much smaller than it's actually supposed to be representing, which is misleading. Much smaller if the vertical axis does not begin at 0. And then when you do this, if you were ever doing it in real life, don't use pictures, because as soon as you scale up an image, it's going to make one seem wider. Like this little Windows bar seems really narrow. This Mac one is a huge wide thing because you just expanded an image. And so it just kind of makes it seem like Mac is a really dominant answer here, which, I mean, it is the most common answer, but it is much more clean and meaningful to just use bars and to not make one category seem like 10 times larger than another, because that's what's looking here. It makes it look like Mac's 10 times the size of the Windows, when, what is that, 75-ish% is not 10 times 15%. So that's the only thing I'm going to note here. This is misleading because it makes our Mac category appear 10 times larger than our Windows category. So not really anything to do on these, but a couple things just to be mindful of, especially if you're told to find what's misleading about some particular graph or something. So that's why I wanted to go through those for displaying categorical data sets.